Hello student, my name is Amrita Dubey, working as a senior assistant professor in School of Pharmacy, BBD University. The name of subject is Physical Pharmaceutics Second, BP403T, and the today's lecture is Concept of Suspense. So today we will discuss in detail about the suspension and many more principles related with the suspension. Let's start. So here are the content which I have shown in this slide. That is, first we will discuss about the definition, then classification, advantages and disadvantages, types of suspension, formulation of suspension, theory of suspension, related with the principle and theory of the suspension. Dispersion system. So first of all, we have to understand what is the dispersion system, because suspension is a type of dispersion system. So before explaining or discussing the suspension, we have to understand about the dispersion system, that what is the dispersion system. A dispersion is defined as a heterogeneous system in which the internal or dispersed phase is uniformly dispersed in the external phase or dispersing medium. So, what is the dispersion? Dispersion is defined as a heterogeneous system in which the internal or dispersed phase is uniformly dispersed in the external phase or in the dispersion medium. Means the dispersed phase is uniformly distributed in the dispersion medium, but it will not homogeneously solubilize. Means there will be two phases or there will be two system in which one phase will call as dispersed phase and another will call as a dispersion medium. It may be kept in a state of dispersion for prolonged periods with the aid of suitable dispersing agent. That is, state of dispersion, we can maintain the dispersion system in a stable form or in a stable manner by adding some suitable dispersing agent, which will help in the formation of a stable or a suitable dispersion in which dispersed phase will be uniformly distributed in the dispersion medium, and these all the characteristics will be achieved by suitable dispersing agents. Now, types of dispersion. So, types of dispersion are as follows: coarse dispersion, fine dispersion, molecular dispersion, and colloidal dispersion. So, the type is mainly div- divided or classified on the basis of particle size. And what is the particle size? Depending on the size range, the system, that is the dispersion system, has been classified into four types. And what is the dispersed phase? So dispersed phase is mainly particles which are distributed uniformly in the dispersion medium. So coarse dispersion means the particle or the API which is suspended in a medium, that is known as coarse dispersion, means size will be more than 1 micrometer. Fine dispersion, in which the particle size range will be minimum to the coarse dispersion, and depending upon the size, this is called fine dispersion. Molecular dispersion, in which particle size will be much more shorter, that is called molecular dispersion. Colloidal dispersion, in which the particle size will range from a solution to the coarse dispersion from 1 to 1000 micrometer, that is known as colloidal dispersion. So, dispersed system. The term dispersed system refers to a system in which one substance, that is the dispersed phase, is distributed in discrete units throughout a second substance, the continuous phase. So, dispersed phase will be continuously discreted throughout the second substance, that is known as continuous phase. Suspension are heterogeneous system consisting of two phases. So, in the last slide, we see that a dispersion system consists of two phases, disperse phase and dispersion medium. So, what is the dispersed phase? That are the particle of very size range, and dispersion medium can be a water or any fluid based liquid. So, dispersed system, a solid, a liquid dispersion in which the particle size is more than colloidal size is known as dispersed system. So dispersed system consists of dispersion medium and dispersed phase. That is, aqueous or oily can be there, or water or oil and aqueous solution can be there. So suspension. Now in this slide we will mainly discuss about the suspension. So what is the definition of suspension? A pharmaceutical suspension is a coarse dispersion in which the internal phase or therapeutically active ingredient is dispersed uniformly throughout the external phase. So, what is the suspension? A pharmaceutical suspension is a coarse dispersion in which internal phase, that is thermodynamically active ingredient, is dispersed uniformly throughout the external phase. That is known as suspension. The internal phase consisting of insoluble solid particles having a range of size between 0.5 to 5 micron, which is maintained uniformly throughout the suspending vehicle with the aid of single or combination of suspending agent. So, internal phase mainly consists of what? Insoluble solid particle having a range of size which is maintained uniformly throughout the suspending vehicle with the aid of suspending agent. So, internal phase which size is very small that can be suspended in a suspending medium with the help of suspending agent. Before, when suspending agent is not discovered, at that time we have to prepare it very carefully and as the requirement. The external phase, that is the suspending medium, is generally aqueous in some instance, may be an organic or oily liquid for non-oral use. So the external phase, that is suspending medium, is generally aqueous in some instance, may be an organic or oily liquid for the non-oral use. Now, what are the desired feature which should required or should be corrected in terms of features in pharmaceutical suspense? So, what are the different features? The suspended particles should not settle rapidly, and sediment produced must be easily resuspended after shaking. Second property, it should be easy, not very watery or should not contain. It should have pleasing odor compatibility. It should have good syringeability. It should be physically, chemically, and microbiologically stable. Parenteral or ophthalmic suspension should be sterilized. So these are some desired feature in the pharmaceutical suspension which can be asked on the features which is required for the ideal suspension is shown here. Antacid oral suspension, antibacterial oral suspension, dry powder for oral suspension, analgesic and suspension, analgesic apna, anthalmate oral suspension, anticonvulsant oral suspension, antifungal oral suspension. Classification based on general classes. Oral suspension example is paracetamol and tetracycline hydrochloride suspension. Externally applied suspension, calamine lotion. Parenteral suspension, procaine penicillin G, insulin zinc suspension. So these are the classification based upon the use, that is by the oral route, by the topical route, or by the route of mouth. Based on proportion of solid particle. Dilute suspension. Concentration ranges from 2 to 10% weight by volume. Concentrated suspension. Concentration ranges from 50% weight by volume of solid. So dilute and concentrated, when they are separated with a semi-permeable membrane, then particle will move from higher concentration to a lower concentration. This is called the surface tension. Now based on size and solid of the particle. So coarse suspension having particle size of suspended solid is less than 1 micron in size are called colloidal suspension. Coarse suspension. So what is the coarse suspension? You can see here in the diagram that the particle size of the comparatively small Yogia suspension having particle size of greater than about 1 micron in diameter are called as coarse suspension. Particle size less than 10 to the power minus centimeter, that is known as true solution. Particle size 10 to the power minus 4 centimeter, that is known as colloidal solution. Particle size greater than 10 to the power minus 4, that is suspension. What are the advantages? So suspension can improve chemical stability of certain drug. Drug in suspension exhibit higher rate of bioavailability than any conventional dosage form. Order of bioavailability: solution, suspension, capsule, and compressed tablets. So physical stability, sedimentation, compaction can cause the problem. It is bulky and sufficient care must be taken during the handling. It is difficult to formulate. Uniform accurate dose can be achieved. Uniform and accurate dose cannot be achieved. It is difficult to formulate. Uniform and clear cannot be achieved unless suspension are packed in unidosage form. Now properties of suspension. So everybody know the sedimentation is a very important property of any suspension. Sedimentation means scaling of particle floccules occur when gravitational force is liquid dosage form. That is V sedimentation is equal to d square 18 ps minus p naught g. So what is the d? Is the difference of diameter. R is the radius of particle. Vd sedimentation velocity in centimeter. Density of dispersed phase, density of dispersion media, the curator gravity, viscosity of dispersed minimal in poise. Now Stokes equation, limiters of Stokes equation. Stokes equation applies to special particle in a very dilute suspension, particle which freely settle without chicken, particle with narrow physical or chemical attraction. So these are the Stokes equation. Now sedimentation parameter. Sedimentation parameter first is sedimentation volume or height for flocculated suspension. So sedimentation parameter, sedimentation volume F or height for flocculated suspension. Sedimentation volume is a ratio of ultimate volume of sediment Vu to the original volume of sediment, that is V0, before settling down. So sedimentation volume F is equal to Vu upon V0. Vu is the volume of sediment and V0 is the sedimentation before settling down, where Vu is the final or ultimate volume of sediment. Now what are the sedimentation parameters? F has value ranging from less than 1 to greater than 1. F is less than 1, then Vu is less than V0. F is equal to 1, then Vu is equal to V0. The system is in flocculated equilibrium and show no clear supernatant on standing. That is F is equal to greater than 1. Vu is greater than V0. Sediment volume is greater than the original volume due to the network of flocks formed in the suspension. So sediment volume is greater than the original volume due to the network of flocks formed in the suspension. Now sedimentation volume. So suspension qualified by sediment volume F 0.5, F is equal to 1, F is equal to 1.5, that is Vu upon V0. Sedimentation volume reach the volume of fraction extra method. So here you can see the height vary from VU to V0 with a different height as shown in a measuring cylinder. Degree of flocculation, that is known as beta. It is the ratio of the sedimentation volume of the flocculated suspension F to the sedimentation volume of the deflocculated suspension F infinite. So beta is equal to F upon F infinite, that is VU upon V0 upon VU upon V0 deflocculated. The minimum value of beta is 1 when flocculated suspension sedimentation volume is equal to the sedimentation volume of deflocculated suspension. So the minimum volume or the minimum value of beta is 1. Brownian movement is shown by or is mainly seen in the suspension if a particle size is about 2 to 5 mm. When the size of the dispersed particle approach that of colloidal suspension, Brownian movement is seen. That is, if the particle size ranges in the colloidal range, particle will move in a zigzag motion so that they can disperse in a dispersion medium throughout in a uniform manner. That is known as Brownian movement. That is equal to RTT upon N3 pi n R. What are the difference between deflocculated and flocculated suspension? So deflocculated, in this system solid as present as individual particle. They also exhibit aggregation but comparatively lower than flocculated. Pleasant appearance because of uniform dispersion of particle. Particle exhibit repulsive forces and particles settle independently. In this system, solid aggregate by forming chemical bridges and slightly sediment and supernatant layer is formed. Particles exhibit attractive forces. They settle as flocks. Means in the flocculated suspension, particle will show the weak van der Waals force of attraction, and when the particle will attracted by each other, they form a flux which is having a loose aggregate of the particle, and when external force is applied, this flux should be separated out as an individual entity. But in deflocculated suspension, there is no kind of flux formation and particle is uniformly dispersed in a dispersion medium. Rate of sedimentation is slow and size of particle is small. Rate is high as flocks are collection of smaller particles. Particle exist as separate entities. Particle form loose aggregate. Bioavailability is relatively high. Bioavailability is comparatively less because in this system you can see in the picture particles are collected by the weak van der Waals force of attraction and they form the loose aggregate. So if the particle will be present in this form, bioavailability will be low. Now the formulation of suspension. In this slide we will mainly discuss about the component related with the formulation of a suspension. So, formulation of suspension. The formulation of a suspension depends on whether the suspension is flocculated or deflocculated. Three approaches are commonly involved: use of structured vehicle, use of controlled flocculation, combination of both the methods. So, mainly three components are used for the formulation of suspension. Now here you can see flow chart of formulation of suspension. Finely divided particle. Now these particles are added to the dispersion medium. Weighting agent is added because there is no interaction between the dispersed phase and the dispersion medium. Deflocculation suspension will be seen or formed. Now, addition of structured vehicle, flocculating agent, flocculating agent are added. Now, deflocculated suspension is external vehicle, flocculated suspension, addition of external vehicle. Now, flocculation suspension is external liquid vehicle. So, in this system, the flow chart of formulation of suspension we can see in this flow diagram, and by understanding the concept of how the ingredient will be added, it can be seen. Now, ingredient for formulation of suspension. First is the wetting agent. They are added to disperse solid in continuous liquid phase. Flocculating agent. They are added to form the flocks of the drug particle. Thickeners. They are added to increase the viscosity of suspension. Buffers and pH adjusting agents. They are added to stabilize suspension to a desired pH range. Osmotic agent. They are added to adjust osmotic pressure comparable to the biological fluid. They are added to impart desired color to a suspension by adding the coloring agent. Preservative. They are added to prevent microbial growth. External liquid vehicle. They are added to construct a structure of the final suspension. So these all the ingredient which have been shown in a tabular form is playing a very important role in the formulation of a good stable suspension. Now wetting agent, so they are mainly added to disperse the solid. Flocculating agent, they are added to form the flocks of the drug particle. Thickener, they are added to increase the viscosity. Now preparation of suspension. So preparation of suspension following consideration are important for manufacturing. Selection of right material that go into the manufacture, the step involved and their sequence in the manufacture, preservation and storage of the product. Steps in the formulation of suspension. Steps involved in formulation of suspension. 1, 2, 3. Grinding or levigating of insoluble material. All soluble ingredients are dissolved in same proportion of the vehicle and added to smooth paste to step 1 to get the slurry. Step 3. The slurry is transformed to a graduated cylinder. The mortar is rinsed with successive portion of the vehicle. Grinding or levigating of insoluble material. All soluble ingredients are dissolved in same portion of the vehicle. The slurry is transformed to a graduated cylinder. The mortar is rinsed with successive portion of the vehicle. Now step 4. Decide whether solids are suspended in a structured vehicle and the flocculated and then suspended. Make up the disperse to the final volume by adding suitable suspending agent. So, whether the solid are suspended in a structured vehicle, flocculated, then suspended, make up the dispersion. Now, grinding or levigating of insoluble material. All soluble ingredients are dissolved in the same portion of the vehicle. Added to smooth paste to step 1, get slurry. So mainly three steps are has been shown: grinding or levigating of insoluble material. All soluble ingredients are dissolved in the same portion of the vehicle. The slurry is transformed to a graduated cylinder. The mortar is rinsed with the successive portion of the vehicle. Step 4. Decide whether solids are suspended in a structured vehicle, flocculated and suspended. Make up the dispersion to the final volume by adding suitable suspending agent. So I think today we discuss the main principle related with the suspension, different formulation factor, different kind of suspension, and what are the different ingredients which are added to stabilize a suspension. We discuss in this slide. So hope students has a better and good idea about the suspension. Thank you.